All right. So, thanks for showing up, everyone. Welcome to Baddies in Tech Try Hack Me Night. We're going through the intro to offensive security and a room. And right now we are on the web application security room. Um, I have my dog in my seat with me, so if I'm if I ever awkwardly stop talking, it's because she is, I don't know. I think she wants to learn how to hack too. We'll see. All right. So, um, oh, and what I was going to say as well was, you don't have to feel like you have to come off mic if you don't want to. And as far as like when I ask questions and stuff like that, it's totally fine. And it's not awkward for me at all. Or, if you do want to, that's also perfectly fine. As far as the recording goes, it's only recording my voice, like my personal voice, but it's not recording the audio from when people talk. So if you review the VOD, it'll probably sound like a one-sided conversation anyways. All right. So web application security. I think this one is kind of an interesting one. Has anyone done anything with web app? Maybe in CTFs or at work or anything like that? I wish I could stop this thing from scrolling, but I can't, unfortunately. Okay. So we have here, looks like TryHackMe has like a little web app, oddly enough, in their little screen here. What does it say? Every one of us uses different programs on our computers. Generally speaking, programs run on our computers using our computer's processing power and storage. Moreover, to use a program, we need to install it first. What if we can't use any program without installation? I think that's a really good question. I hadn't even thought about that when thinking about web app, actually. A web application is a program that we can use without installation as long as we have a modern standard web browser such as Firefox, Safari, or Chrome. Consequently, instead of installing every program you need, you only need to browse to the related page. The following are some examples of web applications. Webmail such as Tootnoa, ProtonMail, Outlook, Gmail, online office suites such as Office 365, Google Drive, Zoho Office, and online shopping like Amazon, AliExpress, and Etsy. I know we've all shopped there. We've probably all gone to some of these websites. I know I do, at least daily. Gmail being the top one, and Office 365 probably being the second. Yeah. Hey, there's nothing wrong with that. They have some good stuff up there. So um I actually just purchased a little like a little mirror from there. Um yeah. Thousands of more oh, thousands of more examples provide a myriad of services. Other examples include online banking, money transfer, weather forecast, and social media. So basically, a web app is anything that you can get to without having to install anything else other than your browser, which is kind of cool when you think about it. Imagine having to, well, outside of a phone, but imagine having to download like, I don't know, the Twitter app just to browse Twitter or like Instagram or Gmail. Like you don't have to download 80,000 apps to your computer just to go to a website. I think I remember that. And they came with like CDs, right? Like discs or yeah. Yeah. I do kind of remember that actually. Because I didn't have internet growing up. 1000%. I didn't get internet until I was like maybe 16 years old. We did not, that was not a thing. um, the idea of a web application is that it is a program running on a remote server. A server refers to a computer system running continuously to serve the clients. In this case, the server will run a specific type of program that can be accessed by web browsers. Consider an online shopping application. The web application will need to read the data about the product and their details from a database server. A database server is used to store information in an organized way. Examples include information about products, customers, and invoices. A database server is responsible for many functions, including reading, searching, and writing to databases. The online shopping web application might need more than one database to access, for example, a products database, a consumers database, a sales database, and I'm sure we could probably guess what each one of those already has in it. And we can see the amount of information stored in any online system. I feel like I might have skipped the word information stored in any online shopping system. Suppose an attacker manages to exploit or hack the web application and steal the customer's database. In that case, this will lead to a significant loss for the company and its consumers, which makes a lot of sense. The database has a lot of really good information in it about customers or people. Like at a job I previously worked at, our databases were huge, and they had like so much information. You had to piece it together if like since it was the gaming industry, like if I wanted to look up, for example, my gaming account, although I don't gamble, but I had test accounts. If I wanted to look up my test account, I would have to piece together different pieces of information. Like I would know like my name is mapped to like a certain attribute. And then that attribute then points me over here and I go and write a query to grab that attribute from this other table, and it can give me the address, or it might even have information that's hashed. A lot of the information would be hashed and you'd have to decode it as well. So those are some real life examples of database outside of online shopping. The image below shows searching for an item on an online shopping site. In the simplest version, the search will take 4 steps. Let's see. Okay. Oh, I think it makes like the picture black and I'm not sure why. Okay, so we have our person does a search to the online web app. The search then goes to the products database and returns the result to the online web app that then returns the result to the customer. Makes a lot of sense. The customer enters an item name or related keywords in a search field. The web browser then sends the search keywords to an online shopping web application. The application queries, searches the databases for the submitted keywords. The product database returns the search results, matching the provided keywords to the web application. The web application formats the results as a friendly web page and returns it to the user. And that makes a lot of sense as far as the flow here goes for us. From the user's perspective, They will only access an elegant online shop where all the technical infrastructure is hidden. Many companies offer bug bounty programs. A bug bounty program allows the company to offer a reward for anyone who discovers a security vulnerability or weakness in the company system. The main condition is that the vulnerability found is within the bug bounty scope and rules. Among many others, Google, Microsoft, and Facebook have bug bounty programs. Discovering a bug can earn you a few hundred US dollars to tens of thousands of US dollars, depending on the severity of the vulnerability, i.e. the weakness you discovered. Does anyone like follow the bug bounty community out there? Really? Yeah, that's awesome, actually. I found out about it because when I created my Twitter, I started following like a bunch of cyber. I guess I was following people with cybersecurity in their names or cyber anything. And I somehow landed on the bug bounty side of Twitter. And I could not figure out, I was like, what am I looking at? Because I kept thinking like, okay, so these people are doing hacks or whatever, but like, what am I looking at? Like, I'm super new to cyber, had no idea. Come to find out, it was the bug bounty community. And the work they do is quite interesting because it not only involves like just the bugs, I guess you could say, or the vulnerabilities, but they also have interactions with legal and they have to sign contracts and stuff like that because you can't just go out and, hacking people's stuff and saying, hey, I found a bug in it. That's not legal. We have laws against that in the United States. That's as far as I can go with that. Let's see. What do you need to access a web application? The answer is most likely going to be browser. Let's see. Hooray, we got it. It was browser. It was definitely browser, which makes sense. I mean, I like the way they put the whole browser aspect of this. It puts it into perspective. Let's see. Now we're on to web application security risks. Let's say that you want to buy an item from an online shop. I keep feeling like I'm missing words, but I'm not missing words. It's the sentence structure. There are certain functions that you would expect to be able to do in this web application. Most straightforwardly, the online order might go as follows. Log into the website, search for the product, add the product to shopping cart, specify the shipping address, provide payment details. Yep, that's exactly how it goes. Go to Amazon.com, search for something that you probably don't need, add it to your cart. They already have your shipping address because you already have an Amazon account. And then they probably also already have your card information added to their website because it's saved. Let's see. Oh, yeah. Uh-huh. Yeah, that's true. That's actually true. Or you could just, wing it. You got 15 cards up there and you just hope that the one that Amazon picked is the one that actually you can shop with. Yeah. There are a few main categories of common attacks against web applications. Consider the following steps and related attacks. Log into the website. The attacker can try to discover the password by trying many words. The attacker would use a long list of passwords with an automated tool to test them against the login page. I think we did something like that the other week, or maybe I did. I can't exactly remember. Search for the product. The attacker can attempt to breach the system by adding a specific characters and codes to the search terms. The attacker's objective is for the target system to return data that it should not, or execute a program it should not. Provide payment details. The attacker would check if the payment details are sent in clear text or using weak encryption. Encryption refers to making the data unreadable without knowing the secret key or password. Makes a lot of sense. The middle one here, search for the product. I remember I think I was reading something about SQL injections, and basically what they were saying was, as long as you can put text into it, you can attempt the SQL injection of some sort, with maybe trying to get it to return some information, or I don't know why an attacker would try to drop a table unless, it's hacktivist type stuff, I guess, because I would think information is more, downtime is probably more ideal for hackers. We cannot cover everything, but we will present a few formal categories from OWASP's top 10. Don't worry if these techniques sound alien to you. TryHackMe walks you through each vulnerability. Has anyone heard of OWASP's top 10? They're like the, yeah. Nice. Yeah. It's interesting. I guess it was kind of shocking that they have these out there and websites are still vulnerable to them, I suppose. I don't know. I'm not a website creator, developer. Identification and authentication failure. Identification refers to the ability to identify a user uniquely. In contrast, authentication refers to the ability to prove that the user is whom they claim to be. The online shop must confirm the user's identity and authenticate them before they can use the system. However, this step is prone to different types of weaknesses. Example weaknesses include allowing the attacker to brute force, try many passwords, usually using automated tools to find valid login credentials, allowing the users to choose weak passwords. A weak password is usually easy to guess. Storing users' passwords in plain text. If the attacker manages to read the file containing the passwords, we don't want them to be able to learn the stored password. And then we have some usernames and passwords here. We got Ann with Freedom One. That's definitely on the list of what is it, like the top 1,000, 10,000 passwords or something like that? There's a list. Yeah, most commonly used passwords. I think, yeah, Freedom One it has to be there. I don't even need to check to know it's there. And so it's Batman 2020. I'm gonna go on a limb and say that one's in there too. And then we have Beth, which has a password with some capital letters, number. Seems good. I mean, seems like a decent one compared to the other options we have here, of course. Broken access control. Access control ensures that each user can only access files, documents, images, etc., related to their role or work. For example, you don't want someone in the marketing department to read the financial department's documents. Example vulnerabilities related to access control include failing to apply the principle of least privilege and giving users more access permissions than they need. For example, an online customer should be able to view the prices of an item, but they should not be able to change them. That's a really good one. Being able to view or modify someone else's account by using its unique identifier. For example, you don't want one bank client to be able to view the transactions of another client. Being able to browse pages that require authentication, logging in as an unauthenticated user. For example, we cannot let anyone view the webmail before logging in. All of these make sense. This one right here, being able to view or modify someone else's account by using its unique identifier. I think one of the couple of years ago, maybe it was 1 or 2 or 3 years ago, people buying tickets to some cybersecurity conference, they were able to, like, if you were, and I know it sounds crazy, I'll try to find the article on it. Like if you were, person number 51, if you put in, 50 into the URL up here, like it would say like, I don't know, like person 51, right? Like hashtag person 51. And then boom, you're on your page for, your tickets that you purchased. But if you went ahead and put in like person 50, you would be able to see who the person was that purchased the ticket right before you. And it was a really big deal because, it's a cybersecurity conference and they failed like one of the first rules of this one, being able to view or modify by using its unique identifier. Like you shouldn't be able to put in 51 and get to, or 50 to get to the previous person. Injection. An injection attack refers to a vulnerability in a web application where the users can insert malicious code as part of their input. One cause of this vulnerability is a lack of proper validation and sanitization of users' input. You'll notice this in like websites where they are asking for your phone number. And if you start typing like your name, it won't let you put your name in the phone number area. That would be a good, that's like good validation for the users to like not be able to put information into a field where that form is not accepted. Let's see, cryptographic failures. This category refers to failures related to cryptography. Cryptography focuses on the processes of encryption and decryption of data. Encryption scrambles clear text into ciphertext, which should be gibberish to anyone who doesn't have the secret key to decrypt it. In other words, encryption ensures that no one can read the data without knowing the secret key. Decryption converts the ciphertext back to the original clear text using the secret key. Examples of cryptographic failures include sending sensitive data in clear text. For example, HTTP instead of HTTPS. HTTP is the protocol used to access the web, while HTTPS is the secure version of HTTP. Others can read everything you send over HTTP, but not HTTPS. Relying on a weak cryptographic algorithm. One old cryptographic algorithm is to shift each letter by 1. For instance, try hack me becomes This cryptographic algorithm is trivial to break. Using default or weak cryptographic functions, it won't be challenging to break the encryption that use 123 as a secret key. I just really could not say that word cryptographic today. Don't worry if these techniques look challenging or sophisticated at first. TryHackMe has dedicated in-depth rooms to help you understand and experiment with various attacks against web apps. Great. So that was actually really interesting. Identification and authentication failure, broken access injection, and cryptographic failures. Okay. You discovered that the login page allows an unlimited number of login attempts without trying to slow down the user or lock the account. What is the category of this security risk? So we have, what did we say here? A login page allowing an unlimited number of attempts without trying to slow down the user or lock the account. I would say off rip, we know that's not cryptographic because they didn't say anything about reading the text or anything about the text or encryption, decryption. Let's see. We know it's not injection because they didn't say anything about inserting malicious code. This broken access control one sounds really good. The problem with it is that they also don't say anything about users accessing anything that they shouldn't be able to see. So they don't say, like, so right here, being able to browse pages that require authentication as an unauthenticated user. Like, it's not exactly this one either, because we're like, this person is hammering the login page. And so now we have identification and authentication failure. I think this one sounds a lot better, mostly because allowing the attacker to use brute force. That brute force was like the key word here for me, at least, because trying too many passwords, using automated tools to find valid login credentials. Let's see. All right, we got it. You notice that the username and passwords are sent in clear text without encryption. What is the category of this security risk? Any ideas? Yeah, definitely. Cryptographic. Because it's the clear text without the encryption. And I guess that's the key word with the I'm just having a lot of trouble with this word, and it's not even a terrible one. Cryptographic failures. The key is that it has something to do with cryptography, and it's something around encrypting, decryption, clear text, those kind of things. Those are like your key that's telling you that it has something to do with cryptographic failures. All right, now we are on to our practical example. Let's see here. This task will investigate a vulnerable website that uses I just made that word up, I'm sorry. That uses insecure direct object references, IDOR. IDOR falls under the category of broken access control. Broken access control means that an attacker can access information or perform actions not intended for them. Consider the case where a web server receives user-supplied input to retrieve objects like file, data, or documents, and that they are numbered sequentially. Let's say that the user has the permission to access a photo named 1003. We'll just call it 1003. We might guess that there are also 1002 and 1004. However, the web application should not provide us with that image even if we figured out its name. In general, an IDOR vulnerability can occur if too much trust has been placed on that input data. In other words, the web application does not validate whether the user has permissions to access the requested object. Let's see. We'll open up our site here. Oh, okay. It was quick. I thought it would have to like load or something. Oh, and I can't move this. All right, we'll just pretend like the site's not there. Oh, exit split. If y'all don't want to do that. Okay. Well, as a tech person, I'm having issues with tech. Just providing the correct URL for a user or a product does not necessarily mean the user should be able to access that URL. For instance, consider the product page. What is it? Store TryHackMe products 12, ID 52. Let's see if this is a real. Okay, I guess it's not. We can expect this URL to provide details about product number 52. In the database, items would be assigned numbers sequentially. The attacker would try the numbers such as 51 or 53 instead of 52. This might reveal other retired or unreleased product if the web application is vulnerable. Let's consider a more critical example of the URL. We got ID 16. Okay, these aren't real. Okay. It would return, the URL would return the user with ID 16. Again, we can expect the users to have sequential numbers. The attacker would try other numbers and possibly access other user accounts. This vulnerability might work with sequential files, for instance, if the attacker sees 007.txt, the attacker might try other numbers such as 001, 006, or 008. Similarly, if you were ID number 16 and ID number 17 was another user, by changing the ID to 17, you could see sensitive data that belongs to another user. Likewise, they can change the ID to 16 and see sensitive data that belongs to you. Of course, we assume that the system is vulnerable to IDOR. Okay, so it says, click on the site. You will see a page that shows an inventory management system. If you click on planned shipments, you will discover an attacker has managed to mix things up, sabotage the plan. Notice how they send the wrong tires to each assembly line, for instance. They assign scooter tires and motorcycle tires to the bike assembly. If left unfixed, all tires will go to the wrong assembly. We will hack the system back. And undo the attacker steps. On your activity, you can see the activity of one of the users. We have reason to believe this website has an IDOR vulnerability. Okay, so let's click. Okay, so we see inventory management, scooter bikes, motorcycle. Okay, okay, I see what they were talking about here. On a bike assembly, we have scooter and motorcycle tires. And so inventory, this is our inventory and then activity. So I'm guessing my activity, this is me On your activity, you can see the activity of one of the users. We have reason to believe that so we know what IDOR is. So we could try number 12 and just see what happens. No user found. Let's try number 10. And we got Anton. Was that me? I was in Anton. I was Roddy. Okay. So I guess we just guess numbers. The vice president. Oh, I see. Okay, so no user found. So this only goes up to 11, and 11 is a warehouse supervisor. And we know it's vulnerable to IDOR. So that means our thing is going to be on this page. Oh, wow. Okay. So the database administrator has done some things here. Oh, wait. Oh, I guess they want us to click the revert button. Oh, okay. Well, okay, I guess we got the flag. But since we know that this was vulnerable to IDOR, all we did was just go back we know we were user ID number 11 and we went back. We went forward and I think there was nothing there. So we know that none of the numbers could be potentially greater than ours. And then we started going backwards, although we did start at 1 instead of going to 9 directly. And we reverted the changes and we found out that the database administrator did it. That's unfortunate. Okay, so the next one is operating security. I'm thinking we could probably do operating security maybe next week. Just so we don't go through them too quickly, and it's not too much for folks. All right.